Okay, here's the video for the non-calculator book, pages 97 through 104, numbers 10 to 18. So number 10 says, what is the instantaneous rate of change at x equals 3 of the function f given by f of x equals x squared minus 2 over x plus 1? Instantaneous rate of change, you should know, is a synonym. Wow, this board is way off. Instantaneous rate of change is a synonym for the derivative. So f of x is x squared minus 2 over x plus 1. That is a quotient, so we shall use the quotient rule. So we have the high, which is x squared minus 2, and the low, which is x plus 1. High prime, which is 2x. Low prime, which is 1. And put it all together using the formula for the quotient rule, which is low d high, so that's x plus 1 times 2x, minus high d low, which is x squared minus 2 times 1, over low squared, which is x plus 1 squared. So f prime, we want it at 3. And yeah, you could probably simplify this, but we just need the number here. So 3 plus 1 times 2, sorry, 3 plus 1 times 2 times 3, minus 3 squared minus 2 times 1, all over 3 plus 1 squared. And so we just have to simplify this and pay attention to what we're doing here. 3 plus 1 is 4. 2 times 3 is 6. Minus 3 times 3 is 9. Minus 2 is 7 over 16. 3 plus 1 squared is 16. So we get 4 times 6 is 24. Minus 7, which is 17 over 16. Which I believe is a choice. That is indeed choice E, 17 over 16. All right, number 11. It says if f is a linear function and a happens to be less than b, then the integral from a to b of f double prime of x dx is. Well, if f of x is linear, what that means is f of x is a number times x plus another number. It's a line. Okay. We could do this with an actual example. So say f of x was 2x plus 1. We want to integrate f double prime. Well, we can find f double prime. F single prime is 2. F double prime is 0. Sorry. F double prime of x is 0. So really, and this would happen the same way here. F prime of x is just m. F double prime of x is just 0. So we want to integrate from a to b, f double prime dx, but f double prime was 0. Well, if you think about what this means, I need to get the antiderivative of 0. So, what functions have a derivative of 0? Well, constants do. This is really the constant c evaluated from a to b. Well, there's no place to put the a and the b. We don't put it in for the constant. So you would do c minus c, which is also 0. Probably an easier way to look at this number is this is the area underneath the curve of the graph of y equals 0. Y equals 0 just looks like, or just is the x-axis. So what's the area underneath between the x-axis and itself from a to b? Well, the area is just 0. There's no area because the x-axis and the graph are synonymous. So our answer is choice A, 0. Put that down. Okay. All right, number 12. Whoops. Number 12 says, if f of x is given by this piecewise function, the limit as x approaches 3 of f of x is. Well, I really need to evaluate my limits coming from the left and from the right. It's like the Shutter method. You need to see if they agree with each other. So I have the limit as x goes to 3 of ln of 3x. Okay. And I would be coming from the left, technically. Whoops. So technically, we'd be evaluating the limit as x approaches 3 from the left here. And this is just a plug-in. It's the ln of 3 times 3, which is the ln of 9. Now the limit as x approaches 3 from the right, we're going to be using the bottom function, which is x ln of 3. which is 3 ln of 3. Now the question are, you don't have a calculator, so are these things really the same? Because perhaps they're equal. But as you notice, ln of 9 and ln of 3 are both choices, so they couldn't possibly be equal. These are unequal, which I'll explain in a minute, so the limit does not exist, because from the left you have ln of 9, from the right you have 3 ln of 3. Now, why aren't these equal? Real quick, ln of 9 is ln of 3 squared. One property of logs is that if you have a power here, it can come outside the log, and this would disappear. So this is really 2 ln of 3. So 2 ln of 3 and 3 ln of 3 are different in the values. All right, number 13 says the graph of the function f shown in the figure has a horizontal tangent at the point -1, -3, and a cusp at 2, 0. For what values of x between -5 and 5 is the function not differentiable? Points of non-differentiability are discontinuities, corners, cusps, and vertical tangents. All three of those things will correspond to points of non-differentiability. So as we see at 0, we have a discontinuity, and at 2, we have a corner or a cusp. So there's a discontinuity at x equals 0 and a cusp at x equals 2. So our only answers are 0 and 2 only. Everywhere else, the function is differentiable. Number 14, a particle moves along the x-axis so that its position at time t is given by that function. X of t is t squared minus 7t plus 12. For what value of t is the velocity of the particle equal to 0? Well, they gave us position. The velocity is the derivative of position, which would be 2t minus 7. And we want to set that equal to 0 because we want to find out when the velocity is 0. So some really quick math here. T equals 7 over 2 or 3.5. That should be probably the easiest question you may have ever done this year. All right. Number 15, if f of x is the integral from 1 to x squared of the square root of t squared plus 3 dt, then f prime of 2 is. We did this one on your quiz. This is the one that I goofed up on the choices, but this one should have a choice that's right. So we want f prime somewhere. So I want to take the derivative of this thing. The way to do that, so if I have my integral, so let me actually write this out. If I have my integral, the integral from 1 to x squared of the square root of t squared plus 3 dt. The way to do this is to say, okay, well, this equals, you take whatever's here, whoopsie, sorry. You take whatever's in that upper limit, provided it's a variable, and you're going to replace it for t. So I want to take this, I'm actually going to put this on infinite cloner for a minute. I want to take this thing and replace it for the t. But remembering, we also have to take its derivative. Okay? We have to take its derivative because if this is something other than x, this function is of something other than x. So we have the chain rule application. So we also must multiply by the derivative, 2x. So this is f prime of x. It's 2x. The square root of x squared squared is x to the 4th plus 3. So now we want f prime at 2. Well, that's 2 times 2, square root of 2 to the 4th plus 3. 2 squared is 4. 2 to the 4th is 16 plus 3 is square root of 19. So the answer would be choice A, 4 square root of 19. Very easy question if you remember how to do it. All right, number 16, if f of x is cosine of e to the 2x and f prime of x is, I want to write f of x carefully. I want to write cosine of e to the 2x. And then I want to unravel this thing using the chain rule. So I have cosine of stuff. Derivative cosine of stuff is negative sine of stuff times the derivative of e to the stuff, which is e to the stuff. times the derivative of 2x, that's stuff, which is 2. So making this look nice and neat, it's negative 2 sine, really, sorry, what you would do is put the sign last. So it's negative 2 e to the 2x sine of e to the 2x, which is choice E. And again, they almost always ask a double chain rule question. It's one you're guaranteed, almost guaranteed to get. All right, 17, it says the graph of the twice differentiable function f is shown. A lot of people are comfortable with this language. What this means is that f prime and f double prime exist everywhere. So there are no corners or cusps for either the first or second derivative. Which of the following is true? And they're comparing f of 2 to f prime of 2 to f double prime of 2. So what I would like to do is see which one I can get. Well, this is the graph of f. So the y values are the values of f. So f of 2 is 0. Now, f prime of 2. F prime asks whether f, or tells us whether f is increasing or decreasing. So at 2, and everywhere apparently with this function, f is decreasing. So if f is decreasing, that means f prime is negative. Okay? F double prime is about the concavity of f. So the concavity of f, this is a half of a smiley face, so we are concave up. So that means f double prime is greater than 0. Well, now let's try to put these in order. The smallest quantity has to be f prime, because f prime is less than 0. The middle quantity has to be f of 2, because f of 2 is 0. And f double prime of 2 is positive, so that has to be the largest quantity. So f prime is less than f, which is less than f double prime at 2. Choice C. And one more, number 18. An equation of the line tangent to the graph of y equals 3x minus cosine of x at x equals 0 is. So if I have y equals 3x minus cos x, I need to find the equation of the tangent line, which really have to know this. There's the equation of any line. I need my first derivative. Well, sorry, let's not go there yet. What I need to find are x1, y1, and the slope. Well, they told me x1 was 0, so that's easy. Now, what we want to find are y1 and the m. Well, the y1 value comes from the original. It comes from plugging in 0 for x. 3 times 0 is 0. Cosine of 0 is 1. Remember our unit circle? This point where at 0 degrees is 1 comma 0. So we have 0 minus 1, which is negative 1. So my y1 is negative 1, which if I subtract a negative becomes a positive 1 in the line's equation. And now we need the derivative. We need the derivative to find m. Derivatives are slopes. So dy dx is 3. Derivative of cosine is negative sign, but since we're subtracting, we're going to add sign. Now we need to find the derivative when x is 0. So that's 3 plus sine of 0, which is 3. So that's 3. And so our tangent line equation is y plus 1 equals just 3x. Subtract the 1 over, it's y equals 3x minus 1, which is choice D. I think that was probably the easiest problem set of the homeworks.